Load balancing is a technique to improve scalability and availability of your application by distributing the traffic between services. Let's start by a problem statement first. Say you're building an application. We'll call it cornhub.com. It's one server running all your customers, it's serving every one of them, they are happy. Then one day, one of your educational videos go viral. Then the traffic goes through the roof and your server cannot handle it anymore. So it fails, now your customers are not happy. So what do? The first obvious answer would be to throw more power at the CPU. So because it's one single server, you could potentially increase the RAM or the CPU of that particular machine. This is called vertically scaling your server. You can also run more than one instances of your application in the same machine to maximize the resource optimization and use a reverse proxy like Nginx or Caddy to distribute the traffic among these two applications. Now, these reverse proxies, they also support load balancing. Now your application is up and running again and it can handle the load. So the problem seems to be solved. At least the scaling problem is solved. But one fine day, one of your EC2 instances or whatever server you're using, it has some misconfiguration. Or you pushed an update that took it down. So now users are again angry because your server is down. While we improved the single server, it became more powerful, but it's still a single point of failure. So if one of these machines go down, your whole application goes down. How we can solve this problem is by introducing what is called horizontal scaling. So you add more servers. Instead of bulking up the single server, you distribute that much resource between two different machines. Now you have two servers and they can handle your application. So now that you have two different machines, you can rent out a different server for load balancing. So most of the service providers like DigitalOcean, they have their own load balancing services. So you can put one of those load balancing server in front of these application servers. Then the load balancing server will distribute the traffic between these two servers. It can also perform health checks so that when either of the servers go down, it will make sure that the new traffic does not reach the server that is down. Instead, it will reroute the traffic to the server that is up. And just like that, we have handled both the scenarios, the scaling and the high availability. Now let's talk about few of the algorithms that these load balancers use. So we'll start with static algorithms. So static algorithms are basically, they do not depend on your machine. So they are pre-written. So for example, round robin. In round robin, the load balancing server, it will switch between the servers one by one. So for example, it will assign the first request to the server A, then the next request to server B, then the third request to server A again, then to the B again. So it will keep flipping between these two servers. The next technique is IP hashing. So IP hashing, as the name suggests, you take in the IP address of the incoming request, you hash it out, and based on that hash, you decide which server this request goes to. Now, these are more of a static approach, and this might not be the best case for each and every scenario. So you can also have dynamic load balancing algorithms. The first one would be least connections. So for example, if you have two machines, the load balancer will pick the machine for a new request, the machine that has the least number of active connections. If you have 1,000 users and 600 of them are on one server, it will pick the server that has 400 active connections. So that way it will try to balance the load between the two. The next method is least response time, which means that it will pick the server whichever is responding the fastest. And this is a really good one because if you have long running connections, so say you are processing videos, you are processing images, and they are long running tasks. So you do not want to push your users based on the least number of connections, because one server can have less connection, but it is still taking longer to process those requests. So you want to reroute the request to a server that is taking the least amount of time. The last one would be deciding based on the resource. So if one of the servers is taking up, say, 50% of its RAM, then it's better to reroute the request to a server that is taking, say, 10% of its RAM, which means that it has more resource to take up a new computation task. But what if you want your users to always arrive at the same? So this comes in very handy if you are using some sort of local cache at your application server, so that if user A goes to the server A, then the server A already has a hot cache of their data, and it can process the request faster, as opposed to if the request were to go to server B, then it will have to refetch all the data and then make the computation. And you can do that by using these load balancers. Usually they use a cookie, so they assign a cookie to each and every user, so that based on that cookie value, they will pick the server that is handling that particular user. So this behavior that you want your users to always arrive at the same server is called sticky sessions or server affinity. So you basically want to attach a user to the same server, and it can be useful for optimizing based on particular users. This is about load balancing strategies and what sticky sessions are. Now let's take a use case for load balancing and horizontal scaling. So one of a commonly used requirement for application deployment is a deployment should be zero downtime, and that is to ensure the high availability of your application. Now, as we learned, if the load balancer is performing health checks on your server, then whenever the server goes down, it knows that the new traffic should not be routed to that particular server, and it has to go to the server that is live. We can use that behavior and create a zero downtime deployment strategy, and it's called blue and green strategy. Basically, you have two machines. Initially, both of them are green, which means both of them are happily serving the traffic. Say you have a new update coming in. So what you do is you pick a server. Let's pick the first server, and we assign the color blue to it, which means that the server will undergo the updates. So as soon as we assign the label blue or the color blue, what we mean is, hey, we notify the load balancer saying, hey, please do not send any more traffic, just reroute all the traffic to the server that is up. And then we disconnect from the load balancer. We take down the server, we update the code, we restart it, and then the health checks, as they start coming in, the load balancer will realize, okay, the server is up, and then the traffic again goes to both of the servers. Then you pick the server B, you make it blue, and you repeat the same steps, and that way you can deploy your application to both of the servers without having any downtime. So this is the video about load balancing and horizontal scaling, vertical scaling, and which one might work better for you. Similarly, we also discussed the power of knowing load balancing and horizontal scaling to use it in scenarios like a zero downtime deployment. If you liked the video, if you enjoyed learning about these things, please be sure to hit the subscribe button. I'll also be making a video about how you can do it in real life. So maybe we'll use DigitalOcean to do this. We'll have two servers, we'll set up load balancing and all. So yeah, stay tuned in if you like such videos.